All right. So we're going to continue our discussion of the simple sorts by going over our insertion sort. We're going to write out our algorithm. Then we're going to go over the selection sort, and you're going to work with either a partner or by yourself to write out the algorithm for our selection sort. And then we're going to kind of do what we did last time. We used our word array, our word tester. Remember that word object we made in the word tester? And we used it to try out linear search and binary search, right? We implemented binary search, then you guys implemented linear search in there. And we just used that bubble sort app. Remember, we just used the bubble sort in there? I thought you guys could do the same thing. You could do your word in your word tester, but then you would implement the selection sort instead of the bubble sort. Okay? And so I'll show you more when we get to there. But that's what I thought we could do today. So actually apply our sorts and use them in an actual application. I put a couple of links here to help us. So this link I gave to you before, and this is kind of a nice link to visually show us our sorts. So we're going to take a look at our insertion sort. So let's look at our insertion sort. Remember that our sorts work differently with different types of data, and you might be learning this as you're testing all of your sorts. You know, if your data is random or sorted already or reverse sorted. And then one test that we didn't do was a few unique, but they put that test inside of this visual. Okay. Remember, you can hit this button here and you could see how your sorts work. And you could see for nearly sorted, the way that they wrote this algorithm, that for nearly sorted, it's already sorted. So you can see that the insertion sort worked well for nearly sorted. They wrote their algorithm here. You can think it worked a little bit like bubble sort, in which it had like that check to see if it was already sorted. Remember how it had that Boolean check in our bubble sort, and if it was already sorted, it took O1, right? One pass through our array. You can see for reverse sorted, our insertion sort works really badly. Okay. And for random, it worked pretty much like bubble sort. Okay. So it's good to kind of, look at those sorts. And remember that you can hit that refresh button on this page and see all your sorts work at the same time. What if you're only comparing maybe like two sorts? It's helpful to see which ones work faster and slower. So I think that's a cool visual. I like this visual. The only thing I don't like the visual is you can't step through it one step at a time. It does it all at once. I wish we could step through this one. Okay. So for the stepping through process, I'm still going to use my old school applets here. Okay. So we're going to go through the insertion sort, and then we'll go through and we'll write our algorithm. And then you guys we'll go through the selection sort. So let's just go through it one time. And can everyone see this in the back? Do I need to turn off the lights, or are we okay? We're okay? All right. So let's look at what we got here. So remember that in this visual, they use different length bars to represent the different key values, the different values inside of our array. So a longer bar we want to the right, and shorter bars we want to the left. Okay. Let me run it one time. So if I hit run, it'll go through the selection sort, and you can kind of see it running in fast speed. I mean insertion sort. Did I say selection sort? If I did, I meant insertion. We're doing insertion. Traditionally, I've always gone over the selection sort in class. So, yeah, it's our insertion sort. So it worked really, it worked pretty okay. So let's look at it in slow motion, and then we can start writing our steps down. So you can see that it has some variables in here. It has some index holders, right? Some variables that hold indexes, and we can look at their values. So we have a temp. He's over here, so we have a temp. And then we have an outer pointer. He's pointing to the value at index 2. He's in red, if you can't see in the back. I can't enlarge this, sadly. But he's the red guy here. He says outer. And then we have a blue inner pointer. And they're both pointing to index 1. Okay, so when we start out, outer and inner are index 1, and temp is over here. Let's step through it. So in our first step, what does it do? It actually says text down here and it tells us what it did. Have compared inner minus 1 and temp. No copy necessary. Okay, so compared inner minus 1 and temp. Okay. It says no copy necessary, and then what did it do with the value at index 1? It copied it to temp, right? And so that's what it says, have completed inner minus 1 in temp. So it's comparing the temp to inner minus 1, and it says no copy necessary. So you can think about the steps here. The steps were copy inner to temp, the value of inner to the value at temp, compare temp to inner minus 1, okay? And note that temp is larger than inner minus 1, so it says no copy necessary. And then it says we'll copy temp to inner, and it copies temp to inner. And then what happened to outer? Outer moved up 1. Okay? The next step, inner moves up 1. Okay. The value at inner gets moved to temp. It compares temp to inner minus 1. Temp is larger than inner minus 1, so no copy necessary. So what's going to happen? Temp will be copied to inner. Outer will go to outer plus 1. Okay? We'll copy temp to inner. Outer goes to outer plus 1. Next step, what's going to happen? Maybe we don't know yet. That's okay. Outer got copied to temp. Inner became inner plus 1. We moved up inner. Okay. Compared inner minus 1 and temp. Now temp is larger than, well, actually it was larger, so actually we're not going to move him. He's larger than inner minus 1, so no copy necessary. We'll copy temp to the inner. Okay, and then outer equals outer plus 1. Okay, we'll start to see a pattern here. Start to see our pattern. Copy outer to temp. So we'll copy our outer to temp. Inner is going to equal inner plus 1. We compare the temp to inner minus 1. No copy necessary because he was bigger. Temp is larger than inner minus 1. So what's going to happen? Temp's going to go back to inner. Copy temp to inner. Outer equals outer plus 1. Okay. Now outer is going to equal, or temp is going to equal outer, right? So we copy that value from outer to temp. Inner moves up to outer. Or inner equals inner plus 1. Now we're going to see a switch here. We compare temp to inner minus 1. And temp is smaller than inner minus 1, so what are we going to do? We're going to copy inner minus 1 to inner. Okay, that's what it says right here. So when inner minus 1 is larger than the value that you're holding inside of that temporary location, you move him up 1 to make room for this guy, right? So do you see how we're going to move enough of these up one at a time so that we can put him in the right place? Okay. So it says we'll copy inner minus 1 to inner, so we're going to move inner minus 1 to inner. Compare inner minus 1 to temp. Are we going to move inner minus 1 up? Yes, because inner minus 1 is larger than temp, and so we're going to move inner minus 1 to inner. Okay. Compare inner minus 1 to temp. Now temp is larger than inner minus 1, so that's where we're going to insert him. Outer equals outer plus 1. Inner equals outer, so inner is going to go up. Temp equals the value at outer. Now we're going to compare temp to inner minus 1. And what's going to happen to inner minus 1? Yeah, he's going to move over, right? So we compare this guy to this guy. Inner minus 1 to temp. Because he's smaller, we move inner minus 1 to inner. Do the same thing. You compare inner minus 1 to temp. Inner minus 1's larger, so inner minus 1 equals inner. Or inner equals inner minus 1. Compare inner minus 1 to temp. Okay, obviously temp is smaller. So inner equals inner minus 1. Compare inner minus 1 to temp. Inner equals inner minus 1. Compare inner minus 1 to temp. Inner equals inner minus 1. Compare inner minus 1 to temp. Inner equals inner minus 1. And when do we stop? When there is no more inner minus 1. So when inner equals index 0. Okay? So obviously we don't want to index outside of our array. So when inner equals 0, we know we stop. And we can't go any further, so temp will equal inner. We'll copy temp to inner. Outer equals outer plus 1. Okay, our next step, what's going to happen? Do you guys remember? Starting to get this a little bit. So outer equals outer plus 1. Now what does temp equal? Temp equals outer. Inner equals outer. Okay. So temp will equal the value at outer, and inner will point to the same place the outer is. Okay, so when I do this next step, temp, or that value will be copied to temp, and then inner equals outer. Then we just start the whole process over again. Is inner minus 1 greater than temp? It is. So what is inner equal? Inner equals inner minus 1. Inner minus 1 is actually less than temp. So once you get to a spot where either you've hit index 0 or inner minus 1 is less than temp, you move temp to inner. Outer equals outer plus 1. Okay. What's our next step? This will be copied to temp. Inner will point to where outer is. Okay. So that value is copied to temp. Inner equals what outer is. Now we start comparing it. Inner minus 1 greater than temp. Yes. So what do we do with inner minus 1? We move him to inner. Move him inner minus 1, compare him to temp, and if he's greater than, we move him to inner. Keep comparing inner minus 1 to temp, and if he's bigger than, and where are we going to stop on this guy? Yeah, when inner equals index 0, we know, hey, there's no more inner minus 1s to compare to temp. Put temp at index 0. Outer equals outer plus 1. Okay. Value of outer gets copied to temp. Inner will equal outer. We start comparing temp to inner minus 1 again. Okay, so value of outer gets copied to temp. Inner points to where outer is. We compare temp to inner minus 1. Inner minus 1's bigger than temp, so we move him over to inner. Inner minus 1 is bigger than temp. We move him over to inner. Inner minus 1's bigger than temp. We keep moving him over. Moving him over. And finally we get to the point where inner minus 1 is less than temp. It's not bigger than temp. So we move temp to inner. And how do we know we're done with the algorithm? Because our next step was outer equals outer plus 1. So we know we are done and we are sorted when outer equals what's this? This is 0 through length minus 1, so when outer equals length, right? So when outer equals num of elements, or when his index is outside of our num of elements, you can think of it as, if these were index 0 to num of elements minus 1, he would equal num of elements. Okay, if it was indexed 1 to num of elements, it would be when outer equals num of elements plus 1, so like in Maple. Okay. But so when he's outside of your array, that's when you know you ended. Okay. Should we do it once again? Or you guys got it? Huh? Or you do it fast this time. Okay, try to predict what's going to happen. So what's going to happen first? You should kind of know what's going to happen. Something gets copied to temp. What's get copied to temp? Outer, actually. Outer gets copied to temp. Outer gets copied to temp. So outer to temp. And inner and outer are at the same spot, so it's more or less right. But you always copy outer to temp. Okay. Inner equals outer. You compare temp to inner minus 1. He's still smaller, so we're going to move temp back to inner. Outer equals outer plus 1. Copy the value of outer to temp. Inner equals outer. What do we do next? Compare inner minus 1 to temp. It's not greater than, inner minus 1 is not greater than temp. So temp will be copied to inner. Outer equals outer plus 1. Okay. The value of outer gets copied to temp. Inner equals outer. You start comparing inner minus 1 to temp. Here's where inner minus 1 is finally bigger than temp. So inner minus 1 will equal inner. Okay. Inner minus 1 is not bigger than temp, so temp will be copied to inner. Outer equals outer plus 1. The value of outer gets copied to temp. Inner equals outer. Start comparing inner minus 1 to temp again. Move these guys up. Inner minus 1 is greater than temp. We move them up. Here's where inner minus 1 is not bigger than temp. So we move temp to inner. So you kind of see how it's working? Let's run it again. So how is it working? Do you see kind of how it's working? Oops. Let's make a new one. Actually, let's do a big one. Well, maybe that's too big. Okay. So it's taking each object at a time. It's taking each one with this outer, whoever outer is pointing to. It's taking each element, and then it's using that inner to figure out where each of those elements that outer took out belongs. So outer is selecting the element, and then inner is figuring out where he belongs in the array. Okay, so each one, as we move outer out, oops. You can see everything to the left of outer is sorted. Do you see everything to the left of outer is sorted? Now you can already tell that this algorithm is more efficient. How can you tell this algorithm is more efficient? It ends its loop early. Once it figures out that nothing to the left is bigger than that temp variable, it just stops. It doesn't go all the way to index 0 each time. Notice it only went so far. So we have an inner while loop and not an inner for loop. You can tell that the outside is a for loop because outer moves all the way across and has to look at every element. Outer is a for loop. But inner is a while loop. Once he finds that right location, he stops and says, hey, he belongs here, and then it starts over. It starts over with the for loop. So you can tell right away that this is a more efficient algorithm. Inner doesn't have to go all the way, like how bubble sort had to go all the way back each time, right? Yeah. In this algorithm, our second loop doesn't have to run the full length of our array each time. Okay, and we'll see that when we look at our code, we have an inner while loop and not an inner for loop, and that's what makes this simple sort one of our more efficient sorts. Well, as far as simple sorts go. Okay, so let's look at our code for it. And you might have downloaded the code last time for our test, our insertion sort tests in our homework. I had you download the insertion sort code. Okay, if you weren't here last time or you need that code, it is in our homework. And this is the code that came with the book. It is in the simple sorts zip file. Hopefully you were here last time. And it is the Java file that says insertion sort on it. And you can just look at this one up here, but I just wanted to let you know that you do have this code. This is the code that your author wrote. Now, he did use an inner for loop, but his inner for loop does have two Boolean checks that will let it leave the inner for loop early. Sometimes this is implemented with a while loop instead. Okay. In my old text, it was implemented with a while loop. Now, this does have a for loop, inner for loop, but note that it has two Boolean checks. Okay. Notice that k equals I plus 1, so you're starting where outer is. Outer is I. So inner equals actually outer minus 1 in this algorithm. But we have two Boolean checks. So when inner equals index 0, we stop, right? And we saw that in our visual. When inner equal index 0, we knew we stopped, and that's where we put our element. Or we can get out of this for loop early if our item that we're currently at is greater than our current element. So this is where we stay in our loop. So if our item that we're looking at in our array is smaller than current element, that way we know we need to insert the element at that point. So that's what's doing that little comparison there. So did I say that right? Let's make sure. So the item where we're currently looking inside of our array, as long as it's greater than the current element we're trying to insert, so the one that's in temp.
The current element is temp.
Yeah, current elements are temp. So the one that's in temp, as long as he's less than what we're looking for, we stay in this for loop. Less than, yeah. And then where we're at is if it's finally, then he inserts him. And he inserts him right here. Insert the current element into our list at k plus 1. So let's enact this algorithm in our Excel spreadsheet and write our algorithm. So I thought we could just look at the code. We could run through the code visually inside of Excel and write our algorithm like we did before. I think this kind of works a little bit so we can understand our code. And I'm going to try to do it like this today. This is where we need two screens. And we only need to really look at our for loops here to do this. The only way to raise him up is to go right there. Okay. Will this work? Maybe this will work. We'll go like this. All right. So we'll name them the same names that are in our code to make it easy on ourselves. So we have an I variable. They say int I equals 1, so I is going to equal index 1. A lot of times when you look at code, you can draw pictures like this, right? And it's going to go to I less than list.length, so you can think of I going all the way to our num of elements. This is and this code is assuming that our entire array is full of the elements we want to sort. Okay. We have a current element, and he equals the value at list I. So actually, we can make him over here. Element. We'll make him a little RAM box over here. So he's a little memory location. No. What are you doing? All I want is to insert you. Okay, so we have I equals 1, so he's a pointer at an index. And then we have current element, which is actually a value, equals the value at list I, so he equals the number 9. So he can equal a 9 over here. Okay. And then we have int k. And now why did they declare that variable int k outside of our for loop? Do you know why? So we can use that value int k down here outside of the for loop. So if you want to remember a variable outside of a for loop, you have to declare him outside the for loop. Otherwise, you can't see him outside your for loop. So they declared int k up there. And then they initialized him in this for loop to k equals I minus 1. So we'll make our blue guy over here k. I'll move this guy down here. So this guy can be k. And he's initialized to I minus 1. Okay. Here's our Boolean checks. K is greater than or equal to 0. He is. He's equal to 0. And the value at k, which is 5, is greater than the current element. Okay. Notice, wait, is our array already in sorted order? We need to make him unsorted. So let's do that first, too. So we can't have an array already sorted, otherwise we're not really learning our algorithm. Okay. So we don't have to make it completely unsorted, but... And let's make him this long. We'll get rid of these guys. In the essence of time here. Okay. All right. So we do our Boolean check. The value at k is 45. So whenever we have list bracket k bracket, that's the value. It's 45. Is it greater than current element? Yes, that's true. So k minus minus. Okay. So k is now equal to -1. Oh, wait, sorry, not the k minus minus, sorry. God, stop me, guys. So this item is bigger than the current element, so that's true. And k is greater than or equal to 0 is true. So if both of our Boolean statements in our for loop are true, what do? We execute our for loop. Okay. List k plus 1 equals list k. And because we changed our array, I'm going to change this guy really quick. And the reason I'm changing this guy is because I unsorted my array, and current element equals list I, so current element is actually 78, not 9. Okay, so we'll pretend that we did that earlier. So list k plus 1 equals list k. List k plus 1. So the value in list k plus 1 equals list k. Right? List k plus 1 equals k. So he's going to equal 45. Oh, you know what? Sorry. Let's start over. This is where I'm like, oh, I wish I could rewind that. Okay. Let's start over. It's because I started changing my array. Let's just start over. Okay. Let's start over from the beginning here. I equals 1, blah. We got I equals 1. I less than list.length, yes. I, okay. Current element equals list item I, 78. Awesome. We have int k. K equals I minus 1. K equals 0. K is greater than or equal to 0. Yes. I am greater than or equal to 0 because I am 0. Here's where I messed up. List k. So that means this value 45. Greater than current element? No. Because he was 9 before, so when we made him 78, that's where we failed. So that Boolean check fails, so we don't go into the for loop. Okay, so when the Boolean check, remember that's an AND statement there, so both of those things have to be true for us to go into the for loop. So when that is not greater than current element, this item here is not greater than current element, it fails. It goes out of the for loop. We come down here in our code. List k plus 1 equals current element. K plus 1 equals current element. Okay, so k plus 1 is this guy. List k plus 1 equals our 78. Nothing exciting really happened that loop body. Now we're back up to our for loop, because remember our for loop is not ended yet, so you go back up to the for loop. And we do our update action of I++. So I++, I moves over. We drop into our for loop because I is still less than list.length. That is true. Current element equals the item at list I. So now current element equals 12. Okay. K equals I minus 1. So K will equal I minus 1. Now we're going to see our same pattern. This is our outer, this is our inner, right? K equals I minus 1. K less than or equal to 0. Check. Now we check the value. Is the item, or the element at list K, so 78, is greater than 12. Now we got a true. So it's true and true. So we drop into the for loop. The item, or element at K plus 1, equals the item at K. So K plus 1 equals the item at K. We do our update action of K minus minus. Then we do our Boolean check. K greater than or equal to 0, check. Is the element at item, or at K, so list item K, which is 45, is greater than our current element, true. So we have true and true. We drop into the loop. List item K plus 1 equals K. Well, not K, the list item at K. So 45. Okay. And then when you do our update action, K minus minus, and what happens? That first Boolean check now is false. So we drop out of the loop. We drop out of the loop. This K plus 1 equals the current element. So K plus 1 is 0. You equal this element, 12. Let's run it through just a couple more times here. Okay. And then we'll start writing it out in words. Okay. Okay, so we're still in our for loop. Our for loop is not ended. Our outer for loop is not ended. We do our update action of I++. The Boolean check comes back as true because I is less than list.length. Current element will now equal the element in our list at index I, which happens to be 30. So we'll put 30 over here. This is our temp. K equals I minus 1, so K is now equal to index 2. We do our check. K less than or equal to 0, yes. And the element at K is greater than 30, so 78 is greater than 30. Element at K is greater than current element, true, so we drop into our for loop. And what do? We should be getting the hang of this kind of now. We copy K plus 1 to K, right? Or the element at K plus 1 to K. So we copy 30 here. We do our update action. We see if this guy's bigger than this guy. Yes. We make sure K is greater than 0. Greater than or equal to 0, yes. We drop into our loop. We see, hey, the element here, 45 at K. Wait.
I think you copied the wrong one.
Wait, Control Z.
Yeah. You copied 78 to the index 30.
Oh, yeah, I knew that. It's because the other one worked differently. Okay, Control Z. Remember to follow your steps. That's why algorithms are important. You have to follow your steps exactly right. Okay. K plus 1 equals K. K plus 1 is this guy. Equals K. So 78 should have got copied there. That's when we go too fast. That happens a lot sometimes. You think you got it, you go too fast. So we copy the 78 to K plus 1. Then we do our update action of K minus minus. Always make sure you go into your loop again. So K is greater than or equal to 0 is true. The element at K is greater than current element is true. We copy K to K plus 1. K plus 1 equals list item K. Okay? So you would equal a 45. K minus minus. Okay. We do our Boolean check. K greater than or equal to 0 check. Item K greater than current element, false. The AND statement comes back as false. We get out of our loop. And we should know what's out of our loop now. List K plus 1 equals current element. And then we start the whole process over again. I plus plus. We can do it without even looking at the code now, maybe. Copy this guy to current element. So list item I. Our current equals list at I. Then K equals I minus 1. We go into our Boolean check. He's obviously not 0. Compare that guy to the that guy. He's greater than. So what do we do next? Not even looking at the code. What do we do next? K plus 1 equals K, right? Yeah. We start understanding the algorithm here. K minus minus. 45 is bigger than 14. This guy would equal 45, right? K minus minus. Now 12 is not bigger than 14, comes back as a fail. We get out of our for loop, and at the end of our for loop, what do we say? Index K plus 1 equals, or the element at index K plus 1 equals current element. And somehow, did we get a mistake in there somehow? Let's do one more. I equals I plus plus. Current element equals the element at index I. K equals I minus 1. Wait, what happened to my 78? What did I do wrong there? Hold on. Did I have two 78s in there? Oh, I just had two 78s in there, didn't I? Okay, we just had two 78s in there. we let ourselves have repeats. So notice that's fast forwarding. Undo and redo comes in handy. Okay. And what happens if you do have repeats? This is actually a good case. What happens if you do have repeats? What will happen? Let's check our code. So we're here at k equals I minus 1, and we're at the beginning of our for loop here. K less than or equal to 0, and k, or the element at list item k, is it greater than the current element? False. 78 is not greater than 78. Okay, so what happens? We get out of the for loop. And you guys remember what happens out of the for loop? Insert the current element into list k plus 1. Okay, so 78 gets inserted at k plus 1. I plus plus. So when we have duplicates, what happens? It just leaves the duplicates next to each other. Okay. Current element equals the value at I, or index I. K equals I minus 1. We compare 78 to 95. Obviously that fails. Well, that says no, I'm not bigger than current element. We jump out. We say insert the current element into list k plus 1. 95 gets inserted right here. And then I plus plus. And what happens to our outer for loop? Our outer for loop, the Boolean check is finally false. So if I were to write this in words, which I do actually want you guys to do, just to write out our algorithm, we're going to practice writing our algorithm. So I'll show you how to write out the selection sort here in our example of writing out a selection or insertion sort. And then you guys will be in charge of writing out the selection sort. So what was our step 1? We can say something like this. We can even look at our code. We can write a direct algorithm right from our code. Okay. So for every element in our array, and we can write it in pseudocode style. I equals, and we want lowercase I. And let me zoom in on my Word document a little bit. So if I were to write out my insertion sort here, for every element in the array, I equals, actually 1 and not 0, you do start at index 1 inside of this algorithm. I equals 1 to length minus 1. And this is assuming that our array is full. If our array was not full, we'd have a variable called num of elements. And this would be num of elements minus 1. Okay, so a more generic way of writing this would put n minus 1. Like num of elements could represent our n. So I'm just going to put an n here, which represents the number of elements. So that way this would work with an array that wasn't already full all the way. Okay? So for I equals 1 to n minus 1. In fact, sometimes I just get rid of this. Okay. And then you can write the word do here, or you could just, But we know that we're going to do that for all of our elements. This will be a sub-step because it's inside of our for loop. Okay. You could write, current element. Actually, writing it from the code is almost too easy. Current element is assigned the value of or equals the element. In fact, I'm going to write this out in regular language. At index I. I could write it something almost exactly like that. But, in fact, I'll even write my keyword here, assign. But sometimes we write out our algorithm to understand the algorithm better. So sometimes we can write it out in words, such as assign the current element equal to the element at index I. Okay. And then inside of this for loop, we have another for loop. So, and I almost think it makes sense to put a while loop here. So while k is greater than or equal to 0, and the element at k is greater than the current element, so note there's lots of ways that you can write this algorithm out, and you just kind of want to write it out so it makes sense. So while k is greater than 0 and the element at index k is greater than the current element, we want to do these steps. Oh look, Word was smart and he figured out how to sub-index my numbers. That was nice. Okay. And because I made this a while loop, I will put my k equals -1 inside of here. Tell it to stop auto-capitalizing for me. So we'll start. K will equal I minus 1. And then what do we do inside of this for loop? And actually, sorry, because I made this a while loop, actually I got to put the k minus 1 out here, right? To make sure that he's greater than or equal to 0. Dang it. So actually, since I made this a while loop, I will put the k equals I minus 1 up here. So that way we can check him. I'll space them out a little bit so we can read them. Okay, so then we say the element at k plus 1 equals the element at k. And I guess I should write the word index in front of those so it makes sense. All right. So if we have k equal to I minus 1, as long as k is greater than 0 and the element at index k is greater than the current element, then we go ahead and we assign the element at index k plus 1 the value of the element at index k. And that's the only thing that we do in here. And when this while loop, either one of these checks fails, that's when we leave our while loop. Wasn't smart enough to do that. Let's see if it's smart enough to do this. Ah, it is smart enough to do that. Nice. All right, and then what do we do outside of this while loop? So outside, we say, okay, the item, or the element at k plus 1 then equals our current element. So we can write assign the value of the element at index k plus 1 to the 2 current element, which is a value. And voila, that's our algorithm. So notice that you can take the code, you can take your knowledge of the algorithm and kind of write it out. And when I write my algorithms, I usually write them like this as a mix of kind of, human language and pseudocode. If you want to see another way to write this algorithm, there's lots of ways that you can write it, but they all more or less do the same thing. Just, they do the same steps. On that one link I gave you to those simple sorts, just so you know here, they actually write out the algorithm right here as well. So here's another way to write your algorithm. They write it almost all in pseudocode. Okay. Now they have an invariant. Okay. That's when they put that Boolean check in there. So that when it's nearly sorted, okay, it stops checking things. All right. I think that's enough talking, so I'm going to have you guys try our class assignment out. And so what I was going to have you guys do, well, actually, let's look at selection sort together, and then I'll have you guys write the algorithm. So let's look at it together. So we can at least kind of look at it together. I think that's what I had planned here. Let's look at selection sort, and then I'll have you guys write out the algorithm by yourself. Or not by yourself, in groups. So looking at selection sort, let's just look at them really fast here. Let's just see what we see here. Notice that we have it. We have to go through the entire array each time. So you can think of this as our outer for loop. What do we notice about selection sort with all of these? They're all the same speed. Notice that none of them are varying in speed at all. So what can we say about selection sort? It always works in the same speed, whether you have random, nearly sorted, reversed, or unique. It'll always work in the same amount of time. So it's very dependable. It always works in the same amount of time. Okay? Okay. Okay, so let's look at selection sort with fewer items. Hold on. So let me first tell you what these pointers are. So we have an inner pointer, so an inner that's holding the index, and you can see he starts at 1. We have an outer, he's red. He starts at index 0. And we have a min pointer, he's pink. Okay. So notice outer is at index 0, inner is at 1, and min is starting at 0. What is inner doing each time? Inner is moving across everybody each time. What is min doing each time? He's pointing to the minimum each loop. He keeps track of who's the minimum. And what is outer doing? Outer is keeping track of who's already sorted. Okay. So let's just kind of step through it really fast. Okay. So notice that inner is going to move through our array, right? So it says searching for a minimum. Okay. So it's comparing inner to min. Who's smaller? Inner smaller than min. So min gets changed to where inner was. It's comparing inner to min. Inner's smaller, so min's going to move to inner. Comparing inner to min, min is now smaller, so it will not move min to inner, and inner moves up. Notice that inner moves along, comparing everybody to min until someone's smaller than min. Okay, then it moves the min pointer up. And inner keeps going along, and what happens when inner reaches the end? We now know who the minimum is. When you find who the minimum is, what do you do with him? Yeah, you put him right here, and you move outer up 1. Okay. Do you see why this is called selection sort? It's selecting the minimum every loop. Okay. So outer moves up. Everything to the left of outer is sorted. Now it's going to search for the minimum again. So inner moves along, comparing everybody to min. When it reaches 1 that's smaller than min, he'll set min to that guy. When inner moves outside or he reaches the end, we now know who the minimum is. We switch him with outer, and outer goes up 1. Okay. We move inner along. We search for the shortest. We search for the minimum. We've reached the end. Okay. And we put the minimum at outer. Outer moves up 1. We search for the minimum. We found him. Minimum gets put at outer. Outer moves up 1. And when do we stop this kind of process? You can kind of think when we stop it when outer equals, number of elements, or outer is outside the bounds of our number of elements. Okay? So now you can kind of visualize when you're running this thing or when you're looking at the code what's going on. You can think of inner as that inner loop and outer as your outer loop. Your outer loop is keeping track of who's sorted. The index of everything to the left is sorted. Your min's keeping track of the minimum. And then your inner is moving along, checking everybody against min. I think selection sort's easier to think about than insertion sort in a lot of ways. But you can see a lot of their code is the same. So what I'm going to have you guys do is write out the algorithm here of our selection sort. So here's our selection sort code. Okay. Here's that outer for loop. Okay. It sets the current minimum to something. It keeps track of the value of the current minimum and the index value of the current minimum. Notice that those are two separate things. One's the value and one's the index. Here's our inner for loop that's going to check and see who's less than current min. See where he's checking? Are you less than current min? And it keeps track of who the current minimum is. And then, if you're not at the end of your list, or if the current minimum index isn't already equaling where we are in our outer for loop, then we go ahead and switch those guys. Not switch, I'm sorry. We say that current min index equals our list item at I. So you can do kind of like how we did. You just write it out in words. Okay, I just don't want to copy and paste of the code, but you should write it out in words. Okay, and you can work in partners on this. Okay, if you want to. If you turn it in together, make sure both of your names are on it. Okay. Only one person really needs to turn it in. So you're going to write out your algorithm, kind of like how we did in Microsoft Word, but you can write it out in Notepad or Word. Okay, so just how we did, you kind of look at the code and write the algorithm out. And see how long that takes us. But then what I wanted you to do, after you finish writing out your algorithm, you'll go to your word tester. And notice our word tester used bubble sort. Okay, so that we could use binary search in here. Remember how we bubble sorted him? What I wanted you to do then was take your selection sort and copy and paste him into your word tester and make him work for your words. So you would take your whole bubble sort method that's already written for you, which you would do in real life. You would take an algorithm kind of method that's already written for you. You go over to your word tester, paste them in here, and then instead of bubble sorting things, you are going to selection sort them. In order to get this to work, you're going to have to fix up selection sort. Notice that selection sort doesn't have to take in the list because we already have the list. Unless you want to send in the list. I think it makes sense to take them out. Okay, but then you're going to selection sort our list. Okay? So that's our goal today. Write out the algorithm and then use selection sort in our word tester. Okay? And you can work in partners if you want to. So we're writing the algorithm and then using him. That's the idea here.